Hi, we're gonna do some stuff very similar to what we did in class. Hopefully you can get as much out of this as the people who showed up in class got out of it. We'll probably do a couple of different but similar problems. So this is actually from our book. In fact, I'm gonna open up the book. So you had an opportunity to potentially look at this yourself. And so I'm gonna open this up. And so there's this warm-up problem of we've got a table that of people in the park. There were 25 people that we looked at, and we polled whether they were wearing sneakers or not wearing sneakers, wearing a hat or not wearing a hat. And let me get my annotation tool up here. All right. So one of the ways we could also call this like set S, which means not wearing a sneakers. The complement of set S or S prime is a way to say not wearing sneakers. The same way we could call this hat, which means this would be the complement of hat, or H prime is not wearing a hat. And in this, somebody named Andre looks at all this and says, hey, I think there are 21 people who are either wearing sneakers or wearing a hat, okay? Because there is a total of 10 people who are wearing a hat, and there are a total of 11 people who are wearing sneakers, and therefore 10 plus 11 is 21. And the question is Andre right? And usually after people look at this for a while, one of two things they notice. First of all, they notice that, hey, you know, by the way, you added in the 8 twice, so that number's probably too big. What some people will sometimes notice is, wait a second, there's 12 people who are not wearing a hat or sneakers, so this number's too big if there's only 25 people in the table. So we need to subtract out one of those 8s. So let's minus the 8 out. We get 13 people who are wearing hat or sneakers. And as a reminder, a logical or, sometimes people think this means sneakers or a hat, like one or the other. So like the 3 or the 2, but not the 8. But when we use a logical or, it includes, you know, both. So we've got sneakers, hat, or both. And that's what 13 is, which if I add those up individually, it's also 13. The next question is, what's the probability? Well, the probability is just 13 out of our sample space is 25. 13 out of 25 is a fine way to write the probability. Or you could turn that, use a calculator to turn that into 0.52, or you could say it's 52%. Any of those are appropriate. I asked an additional question in class is, can you turn this thing into a Venn diagram? And so the question is, I'm going to kind of label these sections. A, I call that intersection there, B, and this C. Where it goes in the A? Right, the hat, but not sneakers. 2 goes there. What goes in the C? Right here, the right side of the sneakers. Well, that'd be sneakers, but not hat, so that's the 3. And then the 8 is what is in the intersection there. And then the 12 is outside both those circles. I also want to remind you that the intersection there is, it's called the intersection. We can also say that that is H and S, because it is. And we can say it's H and this little upside down U symbol means the intersection. In the same way that when we talk about this whole thing, we can say H or S, means everything there, the 2 and the 8 and the 3. Or we can also write it as HU, oops, just a U there, S. This is known as the union symbol, okay, because it's we've united those two things all together. Okay, that's some of the basic terminology from the other day. And then we did a couple of problems in class, which I'm going to do some that are very similar, but not exactly the same. So if people decide to watch this a second time, they will get something additional out of it. Let's see here. Okay, so we've got our old friend, the born in California or not, and the like veggies or not survey. And the question is, use the addition rule. So what we just learned in the do now is this, what's called the addition rule. That if I want to add the total for a category, totals for 2 categories together, then I've accidentally added the intersection twice, so I have to subtract it back out. That is what's called the addition rule. And so if we were doing A or B for born in California or don't like vegetables, Can you show an example of what the P or B? Can you show these calculations using these numbers? All right, so first of all, we got to make sure we know what we're talking about. So California is this row. We could call this C and the C prime. This is V, but I'm not looking at this row. I am looking at this row. I'm looking at, I'll call V prime. Don't like that. So we are trying to find out the probability of C or, which you can write or we can write union, of B. I'm trying to make that look, of V prime. Okay. So California or not like veggies. Well, if I look at my totals for the rows, the not like veggies is 45. That's like my B. So that's 45. And my C is here. That's my 102. Now, this also asks for probability. So these are, I need to turn these into probability. So these are all out of 140. Okay, I'm going to add them together. But if I do that, I've added this 22 twice. So that right there is the P intersection B, P and B, or in our cases, it's C intersection V prime, because it's the intersection of those two rows. So that 22 I have to subtract out. So that would be an example of showing how that rule works. Is, okay, total for the row, total for the column, but if I do it that way, I have to subtract out the intersection, the and piece. Let me clear that out. I got two more, I think. Scroll down. Okay, next one. I got a technician that is testing for two substances from culture samples for patients from a hospital. Look at substance A shows up in 70% of the cultures, and substance B shows up in 40% of the cultures, and 20% of the cultures had both. So this is where you have to kind of realize, oh, I can make a Venn diagram out of this, but the question is, where do these numbers go? So substance A altogether is 70%. Substance B altogether is 40%. So if I ask you, like, how much, A or B, how many of the cultures that has one or the other or both, I need to know what the union of these two sets are. I need to know what A or B is. The problem is, I don't know what's in the middle here. I don't know if there's 10 in the middle or 20 in the middle or 30 in the middle, except I do, because it's in the problem. If I didn't have this number, I couldn't do this. So there's 20% in the middle there, which means I can say it's 70 plus 40, which is more than 100. So I know that's not going to work, but then when I subtract out the 20, I'm like, oh, almost all of them, except for 10% that are outside, have one of these two substances in them. 20% have both. And then if I actually break this down, this will have, there's 20% with just substance B, and there are 50% with just substance A. And then if I look at it that way, 50 and 20 and 20, oh, there's my 90. I got one more I want to show you here. So if I scroll down here, this is another one. I'll just kind of let you look at it, but I want to point one thing out. There's a bunch of questions I can ask about this. I might ask you about one of these on the Edpuzzle. But in particular, I want to notice, like, I can have class A in a circle and anybody who's not in class A outside the circle. I can't do that with this question. I can't create a Venn diagram with this because my first circle, everybody is either in class A or they're not in class A, which means they're in class B. But for the second one, what do you prefer at recess, basically? There's not a single answer for that. So that second thing, kind of your recess option here, tag, does it go inside the circle or outside the circle? Or playground, does it go inside the circle or outside? Because there are three options here, because this is not a binary question of you're either in the circle or you're not in the circle, you can't do a Venn diagram for this, okay? You'd have to change it. You'd have to make it something like, do you prefer a group sport or individual sport during recess? And then you could do inside the circle or outside the circle. But this one you can't turn into a Venn diagram. Enough for now. Thanks. See you soon.